Hey, how's it going, everybody? Today we have an amazing problem for you guys, right? It's called peak index and a mountain array, right? So this is going to be a great one. So make sure you pay close attention to it, right? So it says an array is a mountain if the following properties hold, right? So the length of the array is greater than or equal to 3, and there exists some index, right? Such that it lies within the first index and the last index of the array, right? And those two properties are true, right? So you can see that, at the beginning of the array, right, there's an increasing sort of a sequence, right? So you can see this by, you see index 1, the number index 1, right, is greater than the number index 0, right? And just like the number index 2 might be greater than the index by index 1, right? So it's going to start off an increasing manner, right? And then it's going to keep increasing up until a particular index, right? Index I, right? And then starting from that index, right, the numbers, right, they start to decrease, okay? So you can see this by, the number index I plus 1, right, is less than the number at index I, right? So, and then it keeps doing that up until the last number in the array, right? It keeps that decreasing sequence, right? So very, very important, right? So now we kind of understand what a mountain array is, right? So let's see what they want us to do with it, right? So it says given a mountain array, right, return the index I such that the number starts increasing, right? Okay. And then we get to that index, right? And then the numbers, they start to decrease, right? So we need to find that index where that's that inflection point, right? Where it increase. So we see the numbers keep increasing, right? And then up to the index, right? The number starts to decrease, right? So we need to find that index essentially, right? That inflection and that point essentially, right? So the numbers start to decrease, right? So we need to find that index where that's happening, right? That's what we need to find, okay? So we must solve it in log of n, right? So this is going to be very interesting for us to do, right? So how can we do it, right? So let's go through an example and then we'll probably, say some thought process later on, right? So you should see this why this one is the number starts to increase, right? Okay. 0 to 1, right? And then after 1, right, the number starts decreasing, right? So that's where we return 1 as the index where the inflection point, right? The numbers stopped increasing, right? And then started to decrease, right? So that's what we need to find, okay? And then for example 2, we see that, the number starts to increase, right? We get to 2, 0 to 2. And then from 2, it starts to go downhill, right? Start decreasing, 1, 0, right? So pretty much the peak, right, number, right? So you can see this by, that's another one right here, right? The number starts to increase, right? 0 to 10, right? And then starts to decrease as well, right? See? So that's why we return index 1, right? So that's kind of the whole thing of the problem, right? So how do we easily find it, right? We could have easily done a linear loop, right? Find the max number, right? And then cause I think the max number does work, for all those different problems, right? All right. Or we could have even done this a different way, right? We just do a linear loop, right? But as we're doing the linear loop, we're checking our previous number, also checking our next number, right? And once we find like an index that satisfies that condition, right, where I'm greater than my previous number, right? So I'm greater than n minus 1, right? Okay. And I'm also greater than my next number I plus 1, right? So I find that index, right, that satisfied that condition, right? Then I simply return true, that's that index, right? But this would be a linear loop, guys, right? But the constraint says we need to solve a log of n, right? So we need to be a lot more creative, right? Because doing all those different comparison, right? Because we're checking the next number, checking previous number, right? That's not gonna work out, do a linear, because we have to solve in log of n. So how can we do it, guys? Log of n, they're pretty much telling us we need to somehow kind of apply binary search code, right? We already know, we're comfortable with this, right? Whenever we need to kind of search for something, right, and they kind of impose this type of time complexity, right? The only thing that can come to mind is obviously some kind of binary search involved. But this problem, how can we do that, right? How can Is it intuitive to do that? How can we do it? How can binary search help us in finding that peak number that we're looking for? Okay, maybe let me see. Let's put our thoughts really quick, right? Down, right? So let's see. Okay, so we see a mountain, right? So the numbers they start to like increase, right? Okay, I'm zooming in so it makes sense to you guys, right? So the numbers they increase, right? And then once you get to a peak number, right, it starts to decrease. Okay, so this is very important, right? To help you kind of easily visualize the what do you mean by mountain, right? It increases and it starts to decrease. So how can we go ahead and solve this problem, guys, right? So what I'm thinking, right, is that, knowing those two facts, right, we know there's a portion where the numbers just starts to increase, right? And then there's a different portion, right, where the numbers just start to going downhill, right? So how can we do that, right? Instead of checking for every number, right, how about we be smart with it, right? We somehow discard, right, half of the array, based on a certain condition, right? We know that's how binary search is, okay? Right? Maybe what I'm thinking, right? So, okay, let's say we calculate the middle element, right? So, 1, 2, 3, 4, 5. So let's say this is the middle element, okay? All right, so we would check, right? Let me see. What kind of check do we need to do, right, to know whether to go left or to go right? Okay, so we know that there's an increasing portion and decreasing portion, okay? Maybe what I'm thinking, right? I'm just thinking out loud here, okay? So I can check myself maybe with the next number, right? So I'm doing that because I want to know in which portion of the array I'm in, right? Right. Okay. So I check, right, if the number that's next, right, that is greater than I am, okay, that lets me know something, right? What it lets me know is that I'm in the increasing portion of the array, right? So I don't even need to worry about any of the elements on my left side, right? I can discard that all those numbers on my left side, right, and continue searching on my right, right? Because I know I'm in the increasing portion of the array because I'm checking with the next number, right? So I'm mid and I check at mid plus 1. Is that number greater than I am? If it is, that lets me know I'm still in the increasing portion, right? I can't discard anything on my left side because, I know the peak number is not going to be there because all those values are going to be smaller, right? Smaller than I am, okay? They're gonna be smaller because I told you the number starts to increase, right, and it starts to decrease, right? So I know they're gonna be smaller than I am, right? So I'm not even gonna worry about this portion of the array. I could just get rid of that part, right, and just focus my energy on this portion of the array, right, and keep searching for that number, right? And I apply another binary search, right, and I ask myself the same question. I'm like, hey, is this number greater than I am? No, it's not, right? So because of that, right, so I can just restrict I'm like, cool, I know that the peak number is not gonna be there, right? So let me just keep my search space to be from here, okay? And then I search again, right? I search again, right? And we apply our binary search and we see, is this number greater? No, it's not, right? And we go ahead and restrict the thing again, right? And then we are left with our answer at the end, right? So it's kind of how this can help us out, right? So we keep shrinking our search space every time asking those questions, right? We keep doing that until the real culprit, right, reveals itself, right? The I'm saying. So that's how we're gonna keep doing it, right? We're gonna keep shrinking the size, right, every time until we get that one index that we're looking for. Right, which is the key to this problem, right? Asking those questions and discarding half of the array every time we're minimizing the number of iterations that we need to kind of solve this, right? Now, can you imagine this? There's like a billion numbers or a billion numbers, right? And instead of checking for every single number, right, we could just apply sort of this binary search, right? And discard half every time and make our searching efficient, right? Can you imagine like a million numbers, guys, right? All you got to do now, right? Instead of linearly searching, right? Just apply binary search to check for the middle element, right? Check is the middle element is the next number, right? That to the right of me, right? Is it greater than I am? Okay. If it's greater than I am, I don't have to search on my left side, right? That's energy I'm not gonna waste, right? I just focus on my energy from mid plus one to and to the right boundary, right? I keep searching that. I keep doing those decision checks, guys, right? Until we are left with that one number, right? The culprit, right? The inflection point, right? The peak number, and then we just exit out the while loop, right? So that's kind of how it is, all right? Hopefully, I kind of convinced you guys with the approach. Let's quickly go ahead and read and do the code, right? The code is going to be relatively simple. So we're going to start off with our left boundary, always 0, and the right boundary to be array at length, okay, a -1, right? All right, so we're good. What we're going to do next, we're going to have the while loop, right? Which is going to be important. So we're on the left is less than the right, okay? We're going to calculate our middle element. Left plus minus left divided by 2. We're doing this to avoid an integer overflow, right? We've done a lot of different binary search problems, right? So something should pop up here for a playlist to kind of help you solidify that concept, guys, right? Very important, okay? And then we're going to do that decision check that we said, guys, right? We're going to do the middle element, right? If it's less than the next number, right, then we know that we don't need to waste our energy searching on our left side. So we keep going to the right. And the other way around, right, when the decreasing portion, we just restrict our search space again, right, to be the middle, from the left to the mid, right? So we know that's where it's going to be, okay? All right, so that's how we keep restricting it, guys, until we're done. And then after we do that, we should be in good shape, okay? Let's press run code, see if everything's fine. Looks good so far. So quick recap. So we just apply binary search, right? Now we restrict our search space every time by asking a series of questions, right? I told you guys why we asked this question, right? We know in which partition we are, right? Which portion, right? Are we in the increasing portion? All right, cool. Let me just keep going to the right, right? Because we know it's not going to be on my left side guaranteed, because, the number starts to increase and it starts to decrease, right? And I'm looking for the peak number, right? So if it's not greater, right, than the next number, right, then we're in the decreasing portion, then we restrict our right boundary to be up to mid, right? Yeah, so let's press run code. Awesome, guys, we're able to pass all the test cases, guys, right? So if it made sense to you guys, let me know that in the comment section. If you guys still have concerns and thoughts, let me know that, tell me anything I did wrong, if you guys, I did a bad job or a good job or not, right? Read the feedback, really useful, and I want to help you guys out a little bit more. So yeah, I want to thank you guys for watching, and I'll see you guys in the next video.